Welcome back, dear students. So in today's class we'll be learning about the particular solution of a differential equation. So in the last class we have seen how to find the general solution. Now in particular solution, what we first do is we'll find the general solution. Okay, and in this case there's one extra case given to you, So if you observe here, this is the case which is given to be extra as compared to your general solution. So this is called initial value. Okay, so this is called your initial value, and this overall problem is sometimes also known as initial value problems. Okay, right. So let's see how to solve this question. So first and foremost, so given is this one. So from here we'll first find the general solution. So bring this minus out there, so you get tan x dy is equals to tan y dx, isn't it? So that's what you get. Now separate the variables, so bring this tan over here, tan y out here, so you get cot y dy. Okay, and here you have tan. Okay, so this tan x goes over here and it becomes cot x dx. Okay, now after that what you are going to do is, obviously you have to integrate. So integrating both sides, so when you integrate both sides, you get integral cot y dy is equals to integral cot x dx. Now all of you know integral of cot is nothing but log sine x, isn't it? I'm sorry, here it has to be y, so it is log sine y, and this integral becomes log sine x. Okay, and if you want to put any constant of integration, that's okay. So if you want to put log c, that is also fine. If you want to put just c, that is also fine. So let me put c here and let me call this to be equation number 1. Okay, now it is given that when x is pi by 4, then the value of y is given to be pi by 2, isn't it? So therefore 1 becomes, so let's see what do we get from equation 1. So we have log sine y. Now in place of y we have pi by 2. Okay, is equals to, we have log sine x, that is sine x is given to pi by 4, isn't it? Okay, so we have plus c. Now all of you know log sine pi by 2, sine 90 degrees 1, and log 1 is 0. So if this entire thing is 0, now all of you know sine pi by 4 is how much? 1 by root 2. Okay, so can I write this as 0 is equals to, so can I write this as log a by b? Log a by b is log 1 minus log root 2, isn't it? Log a by b is log a by b, so plus c is there. So again this is 0, and from here you get c equals to log root 2. Okay, so we got the value of c. So therefore we get from equation 1, so we have log sine y is equals to log sine x plus c, whereas the value c is log root 2, isn't it? So from here you get log sine y. Now call this as a and call root 2 as b. So log a plus log b is log ab. So multiply sine x and root 2, you get root 2 sine x. So if you remove log from both sides, you get sine y equals to root 2 sine x. So this is the required particular solution. So this is how we need to solve this kind of sum. Easy. Pause the video and note down your solution. Let's observe another question. So here it is given that so first and foremost, let's open, no need to open, let's separate the variables. So let me bring y out here and let me take this x out there. Okay, so if I do that, so then you get dy by, so you get y, so 2 is there, so you have dx by 1 minus x square, isn't it? So we have this much. Now you can directly integrate here. So integrating both sides, so we get integral dy by y is equals to 2 times integral dx by 1 minus x square. Okay, now see, this is simple, this is log y, this is log y. So we have 2 into, so can I write this as 1 square minus x square? So if you write this as 1 square minus x square, this is in the form of integral dx by a square minus x square, and its value will be 1 by 2 into a is 1 here. Okay, log, here we have a plus x in the numerator, that is 1 plus x, and in the denominator you have a minus x, that is 1 minus x. Okay, now put a constant of integration out here. See, you get that these two gets cancelled, and call this as equation number 1. Okay, so as per the condition, when x is equals to 2, then y is 1. So therefore we get from 1, so from 1 we get, so log y is given to be 1 is equals to, so we here we have this log. Okay, so 1 plus x is given to be 2, divided by 1 minus, we have x is how much? X is 2. Okay, so we have plus c, this is 0. Okay, so from here what do you get? You get, okay, so 0 is equals to log, so this is, can I say this is minus 3? Yes, so this is this much. So from here, so you get c equals to minus log minus 3. So putting the value of c in equation 1, so we get, so you get, let me use another color here, so you get log y is equals to, you have log, so here you have log 1 plus x divided by 1 minus x, plus c is, in place of c we have minus log minus 3. Okay, so we have minus log minus 3. Okay, so bring this minus log out here. Okay, so you get log minus 3 plus log y equals to log 1 plus x divided by 1 minus x. So again apply log a plus log b, which is equal to log ab. So you get log ab will be minus 3y is equals to log, so you have 1 plus x by 1 minus x. So you can make use of this bracket also. So remove log and log, so from here you get minus 3y equals to 1 plus x by 1 minus x. So this is the required particular solution. Okay, so you may pause the video and note down your solution. Okay, so let's take this question now. So this is given to us. So from here, okay, so let me first take this b squared x to the right hand side. So you get a square y dy by dx is equals to minus b square x. Now separate the variables. Okay, so you have a square y dy, bring this dx out here, you get minus b square x dx. Okay, now integrating both sides, So let's see how much do we get. So you get a square is a constant, keep it outside integral sign, so you get y dy is equals to minus b square integral x dx. Now let's find the integral of this. So you get a square into this becomes y square by 2 is equals to minus you get b square into you get x square by 2. Now put a constant of integration and call this to be equation number 1. Okay, now when x is equals to a by root 2, when x is a by root 2, then it is given that y is b by root 2, isn't it? So therefore we say, therefore from 1 we get, so a square by 2, just write this as a square by 2 into y square. So what is y actually? Y is b by root 2, simple, is equals to, we have minus, write this as b square by 2 into we have x square, right? So in place of x we have a by root 2 square plus we have c. Okay, so we have, just see, observe this carefully. So when you open the bracket, let's see what do we get. So a square b square by 4, that's what you get, isn't it? A square b square by 4. So that's what you are going to get. In the right hand side you get minus, if you simplify this you get again a square b square by 4 plus c. So from here if you bring this out here you get c equals to, after simplification you get a square b square by 2. Okay, so putting the value of c in equation 1. So if you put the value of c in equation 1, we get a square y square by 2 is equals to, okay, so you bring this also here. Okay, so you get plus b square x square by 2 is equals to c. C is a square b square by 2. So you see we have got 2 in the denominator, so all of them can be cancelled. So from here what you can do is you can write this as, okay, so you can write this as, alright, so bring this a square b square also to the denominator. You get a square y square by a square b square plus you get b square x square by a square b square equals to, here 1 is left, b square gets cancelled, a square gets cancelled, and if you simplify this you get x square by a square plus y square by b square equals to 1. Now if you observe this, this is the equation of an ellipse, isn't it? So this is the required particular solution for the given question. Okay, so you may pause the video and note down your solution. Let's have a look at this question. So this is going to be the last question for today, which says we have to first separate the variables. See, here we have y dy, okay, and here we have x and dx, okay, e to the power x dx. Now bring this y out here and bring this entire x to the right hand side. So in that case you get, okay, so you get y dy by y square plus 1 is equals to, you have e to the power x by e to the power x plus 1 dx. Okay, now integrate both sides. So before integrating, what can I do here is, so just look at this. Okay, can I write this as e to the power x plus 1 minus 1 e to the power x plus 1? Can I do that? No, don't do that, for now. So let's leave it like this only. Integrate both sides. Okay, so integrating both sides, so let's see how much do we get. So we get y dy by y square plus 1 is equals to, here you get e to the power x by e to the power x plus 1 dx. Now what kind of integrals are these? Both of these are integration by substitution. Okay, so let's substitute then. So we have to do two substitutions, remember. So let y square plus 1 is equals to, let's say, t. Then from here you get 2y dy is equals to dt. That is, you get y dy equals to how much? You get dt by 2. Okay. And another substitution that I am going to make here is, let me take e to the power x plus 1 is equals to u. So if you differentiate here, you get e to the power x dx will be equals to du. Okay. So therefore we get, or we have, so from the integral, just observe y dy is how much? Y dy is half dt. So bring half outside, so you get dt by, so y square plus 1 is t. Okay, is equals to, we have e to the power x dx is du. So we have du by, so this entire thing was taken to be u. So that's what you get here. Okay, so just observe this. So this is equals to, from here it is half log t, isn't it? So half log t is equals to, this is log u. But a constant of integration, now resubstitute the value of t. How much is t? T is y square plus 1, isn't it? So you get half log y square plus 1 is equals to log u. U is given to be how much? U is given to be e to the power x plus 1, and we have plus constant of integration and call this to be equation number 1. Now it is given, the condition is given out here. Okay, so when x equals to 0, then y also becomes 0. So from this equation, let's see how much do we get. So we get half log y square plus 1 is 0 square plus 1 is equals to log e to the power x, which is 0 plus 1 plus c. So see, we have 0 square plus 1 is 1. So this is log 1, which is equals to, how much is log 1? Log 1 is equals to 0. So that's why this entire thing becomes 0. And e to the power 0 is how much? It is 1. So that's why you get from here you get 0 equals to, this is log 1 plus 1 is 2. So you get the value of c to be minus log 2. Okay, so from 1, so what you can do is, so from 1, if you bring this here, okay, inside log, this goes to the power, so this becomes whole to the power half, and all of you know whole to the power half is square root, isn't it? So from 1 we get log square root of y square plus 1 is equals to log e to the power x plus 1 minus c is minus log 2, right? So minus log 2 is there. Now you know, apply log a minus log b, which is log a by b, isn't it? Which is log a by b. Or else if you want to take this here, you get log 2 in plus log root over y square plus 1. Okay, is equals to, you get log e to the power x plus 1. So log a plus log b is log ab. Okay, so we have small part left here, so 2 more steps are left. So you can write this as log 2 times root over y square plus 1 is equals to, you have log e to the power, you have log e to the power x plus 1. So remove log and log, so your final answer becomes 2 root over y square plus 1 will be equals to e to the power x plus 1. So this is the required particular solution for this particular problem, right? So with this we close for the day. We'll meet in the next class. Thank you very much.